Hello class, this is a video tutorial on determining the equation of a line. So if we're given a gradient, we'll label that gradient m1, and a point A, or any point really, with coordinates x1 and y1, the equation of the line passing the point A, so it's going through that point with the gradient of m1, is calculated by this process. Well, it's a formula really. Y minus y1 equals m1 bracket x minus x1. And here it is visualized. So if we have the point A here, so there's our point A, we have a line passing through it with the gradient of m1, so it has risen 1 when it has gone across. It has risen by m1 when it has moved across by 1, and there's our equation. So I'll demonstrate to you now what it would look like. Okay, I'll just repeat our formula up top here. That is y minus y1 equals m1 x minus x1. Before we continue, let's label everything that we need. So there's our m1, and here's our x1 and y1. Using our formula, we get y minus 4 equals gradient of 2, so 2 x minus x1, which is 3. Evaluating all of our points, this would be y minus 4 is plus 4 equals, expanding the brackets, we get 2x minus 6. Moving everything to one side, leaving y on the left, y equals 2x, subtracting 4 on both sides. Negative 6 minus 4 is negative 10. This here is our equation of the line in gradient intercept form, and we can also change it so that it looks like the following. 0 equals 2x minus y minus 10, or we can just finalize it there. So we have two equations in two different forms. So we have the gradient intercept form here, so we can leave it as y equals 2x minus 10, or we can have it as 2x minus y minus 10 equals 0 for the general form. So I'm going to leave it as both because why not? Once again, here we have our gradient m1, our x1, and our y1. Using our formula once again, it's y minus y1, so minus 4, equals the gradient m1, which is negative 3, bracket 8, should be x minus 8. Expanding our brackets, we get, this stays the same. Expanding our brackets, we get negative 3x. Negative 3 times negative 8 is positive 24. Moving everything to one side, we get y equals negative 3x plus 20, or we can have it as 3x plus y minus 20 equals 0. So I just move this negative 3x to here to make it positive 3x, and this positive 20 is now negative 20. So our two forms are y equals negative 3x plus 20, or 3x plus y minus 20 equals 0. Okay, let's move on now. So this is if we're given the gradient. What happens if we are not told what the gradient is, but instead we are only told that it passes through both points? Okay, well, the trick, well, not really the trick, the only way we can do this is we first need to calculate the gradient between A, B. So we say m, the gradient of AB, is equal to, if we can remember, that's our x1, y1, that's our x2, y2. The gradient is y2 minus y1 over x2 minus x1. So using this formula we get 7, take away 3, over 4, take away 2, which gives us 7 take away 3 is 4, 4 take away 2 is 2, so our gradient m1 is 2. So now, picking one of the points, can't pick both, I'm going to pick x1 and y1 because it's already labeled. Once again, using our formula, I'll write it actually up here at the top so we don't forget. It's y minus y1 equals m1 x minus x1. Okay, we can actually see how I wrote it as x1 and y1. Even though this one is already labeled x1, y1, we could still use x2 and y2 from this labeling that we've done here. Let's move on. So it's now going to be y minus 3, which is y1, equals 2, which is now our gradient, x minus x1, which is also 2. Finishing this off, we get y minus 3 equals 2x minus 4, y equals 2x minus 1. Leaving it as the general form, we get 0 equals 2x minus y minus 1. So finalizing, we have either y equals 2x minus 1 or 2x minus y minus 1 equals 0. One more time, we need to find the gradient between these 2 points. So here's our x1 and y1, x2, y2, and the gradient between A, B, these 2 points, it's y2, so negative 5 minus minus 2 over x2, which is 2, take away 5. 5 minus minus 2, that's negative 5 plus 2, gives me negative 3. 2 minus 5 is negative 3. This gives me a gradient of negative 1. So let's label that m1. That's what we're going to be using now. And once again, let's use our formula to find the equation of the line. Y minus y1, which is negative 2, equals negative 1 outside, x minus x1, which is 5. Evaluating this, we get y plus 2, because minus minus 2, equals negative 1 times x is negative x. Negative 1 times negative 5 is positive 5. It'll become y equals negative x plus 3. Or it'll become x plus y minus 3 equals 0. So both solutions as gradient intercept, we get y equals negative x plus 3, or we get x plus y minus 3 equals 0 as our general form. Okay, so I hope that assists you in calculating the gradient between calculating the equation between 2 points.